The 360 on Energy and Carbon, hosted by 360 Energy. On today's episode, we are joined by Mohammad Doostmohammadi. Backed by a master's degree in chemical engineering, an MBA, and over 15 years of industrial experience in minerals extraction, processing, and wastewater management, Mohammad launched PH7 Technologies in 2020. His aim? To innovate sustainable systems designed to help increase the global supply of critical metals in an economically and environmentally superior way. In doing so, PH7 would not only support mining sustainability, but also help facilitate the world's transition to electrification and clean energy pathways, and conserve water, save energy, and reduce emissions. At PH7 Technologies, Mohammad's vision is being realized through the company's novel closed-loop critical minerals extraction process, which offer an economically and environmentally superior way to extract in-demand minerals, including platinum group metals and copper from recycled materials and mine waste. Now let's get into the episode with Mohammad. Welcome back, Dave and John.
It's really good to be back, and it's good to have you back to keep us in order.
Yeah, ditto on that. I'm not sure about the order thing. Let's see what we can stir up with John. Well, Lysandra's here as well.
I will say I missed you both, and I'm really excited about today's episode. Today, we're joined by Mohammad Doostmohammadi, founder and CEO of PH Technologies. Welcome, Mohammad.
Thank you. Hello, everyone. I'm glad to be here, and it's a pleasure to having this podcast with you and your team.
Thank you. So your background is quite fascinating. Can you share some pivotal moments that inspired you to start PH7 Technologies?
Yes. So I am a mining engineer and chemical engineer, and I have been practicing chemical engineering with a focus on mining engineering, actually, and mineral processing for the last 10, 15 years. I have gone through a lot of different chemical processes, different chemical plants, mineral processing plants, metal extraction from recycling, mining, smelting, pyrometallurgy, so different aspects of metal extraction. And one thing that I always wondered about how we can make it more sustainable was about water. And water is one of my passions. And the reason is that I was born in the middle of a country back home in Iran before moving to Canada, that we had a water crisis. We had rivers that were running for thousands of years and being dried out, being from a permanent river to the seasonal river, and just being dry one after one. Fresh water is being used for industrial application, all turned into the wastewater that you cannot reuse it again. It's just wasted. So, and I see in mining industry, water consumption is huge, and you generate a lot of wastewater that they cannot be reused again. And that's when I was thinking about starting a company that we can address that problem. That's the background of PH7, and the name of PH7 is coming from that as well. So pH of water is 7. It's a neutral pH, and that's why we have PH7 as the name of the company. And it's all about the water, how we can minimize the water consumption and mineral extraction, and how we can eliminate wastewater in mineral extraction.
Mohammad, it's my turn to ask you a question here. So first of all, I'm really pleased that you're joining us. To our audience, I had a chance to speak with Mohammad earlier prior to the podcast. So I'm really looking forward to what we're going to discuss. You know, every company has a kind of a driving force. And what is the core mission of PH7 Technologies, and how does it align with the global push towards renewable energy?
Yeah, so the main driver, I mentioned in the first question, just elaborate on that, was the water, and just eliminate the water consumption in the mineral processing. But the actual driver behind all of this is the critical mineral and the timing of the need for critical metals and critical minerals. And why is the reason? Because if we want to get to our 2050 net zero goals, we cannot achieve that without these critical metals. It's impossible. So let's say you want to do all electrification. We want to replace all the fossil fuels. You need copper to just transfer that electricity. You need cobalt, nickel, lithium for your lithium-ion batteries. You need platinum, iridium for the hydrogen technology as a catalyst. So all of these metals are the heart of renewable energy, and the demand is surpassing supply. And that's the main reason we started PH7. We wanted to address this. We wanted to see how we can accelerate the critical metal extraction and how we can do it in a sustainable manner. So it's not only increasing the supply in a sustainable manner, both economical as well as environmental. And that's where we started the R&D with the mindset of extracting these metals from the supply that is destined for landfill, or it's unextractable, it's getting wasted. And we designed a process that we call it closed loop process to extract these critical metals. And what does it mean? What does closed loop process means is it's a process that extract these metals, increase the supply of these metals, while the chemistry and the chemical being used in that process being reused over and over, eliminating any wastewater, eliminating any water consumption, and eliminating any off gas. So by not generating any GHG emissions, we can extract these metals from the supply that is going to landfill or wasted in the mine as a waste rock and increase the supply to meet the demand for net zero goals.
Wow, I think that's really interesting, because one of the criticisms a lot of people are saying about our net zero future is how dependent it becomes on rare and special materials. And, we need a circular economy and everything for those to go. Now, I understand you've got a process, Solvo-Metallurgy, and I'm not familiar with it. And I wonder if you could break that down, explain it to us, and tell us how it's revolutionary.
So in this process that we designed, we are using Solvo-Metallurgy as part of this process. And the reason that we actually applying that Solvo-Metallurgy is to make this process sustainable. So what does it mean? Instead of really toxic acid chemistry and acid-based chemistry, we are using solvents. And the good thing about solvents, they are like your alcohol, for example. Alcohol is a good solvent, good an example that they can give the audience. When you distill alcohol, you can purify it again. You can condense it again, and the characteristic of the alcohol stays the same. It's not going to be consumed. You just distill it, you condense it again, and it's again your 99% alcohol that we can use. You can remove all the impurities through that system. But if you use acid and you acid involving the reaction, then it's getting consumed and generating wastewater. So all the acid, they react together and then generating lots of wastewater that cannot be reused over and over. So by applying Solvo-Metallurgy into our closed loop system, we developed a media that doesn't involve in the chemical reaction, just hosts the chemical reactions. And that's why we can start reusing our chemistry over and over and over without generating any wastewater or any effluents. So we can regenerate our solution, we can have it back again, and we can reuse it over. That's the whole concept about Solvo-Metallurgy, which is using solvents instead of toxic.
Okay, I think I understand, but I'm getting some of our other questions will broaden that understanding.
So I'll lead on with the next question, and there may be some overlap of what you just conveyed, but maybe this will actually help provide more clarity, or you'll add some more detail. So, our listeners, they just get a little peek behind the scenes without giving away your secret sauce per se, but can you walk through a typical process of sustainable extraction and refining of metals using the pH technologies? Like, what are the cutting edge methods that you're using?
So I believe I can simplify this. Just a simplified prop that we use is we receive the raw materials that contains these critical metals. So like platinum, like rhodium, palladium, copper, nickel, cobalt, different type of critical metals. And maybe it's only 0.1% or even less is these critical metals. And 99.9% is the substrate, is the materials that host those metals, such as different type of ceramics, sand, soil, you call it. Those are just, we don't have any application for them. They are just burying those critical metals. So we receive those materials. And what we do at PH7 and what make us revolutionary in industry is we're attacking only that 0.1%. So traditional method like smelting or pyrometallurgical or heavy acid-based chemistry, they dissolve everything. They actually attack that 99.9%, melt it down, burn it, or dissolve it to get to that 0.1%. We do exactly opposite at PH7. We just attack that 0.1%. We extract that 0.1% selectively, and the rest of the material stay intact. So those materials, those powder that we receive from different suppliers, either from mining industry or recycling industry, goes to our reactor. It will be mixed with our solution, and we call it lixiviant, which is combination of water, solvent, different reagents, and we start dissolving that 0.1% of the metals into the solution, and the rest of the materials stay intact. Next stage, after we dissolve all of those critical metals into the solution, we remove that 99.9% powder that doesn't have a critical metal anymore, and just through a solid liquid separation. And the metal dissolve into the solution, go to the next stage where we extract. We extract them from the solution into the metallic form, and will be reused and will be refined for just recycling them into the industry. And the solution that doesn't have any of those metals anymore, because the metals are already extracted, will be reused again for the next batch. We're regenerating it through electrochemical processes, and we will reuse it again for the next batch, new batch of the raw materials.
For our listeners, it sounds like a very efficient methodology versus what we used to do I shouldn't say what we used to do. I guess in some forms we still do in most cases. So it sounds very promising based on what you just conveyed to me on how this is really efficient and very targeted.
That's true. Just especially in metal extraction, it's a pyrometallurgical process. It has been used forever, just thousands of years. Humankind has been burning everything, melting everything to extract the metals. And we haven't seen a lot of revolutionary technologies to change that in an economical manner. This is very important. And I believe that's something I cannot claim that we can solve and replace 100% the pyrometallurgical method that we are using, but we have a niche market that we can more efficient extract these critical metals from kind of raw materials that doesn't make sense to burn them or melt them. Our process will be more efficient. And we are developing, it's a new technology, and hopefully we can get more of these different type of materials that we can process to our chemistry. And eventually we can get more market share.
Can I ask just two supplementary questions that sort of have been raised by what you've said there? And the two questions are, I'll ask them both and you deal with them how you feel best. One is, what happens to the 99.9% that you're not using? And then the other question is one of scale and scalability of this versus traditional processes.
Yeah, very good question, actually. And that 99.9% depends on the materials, depend on the substrate, metal composition. We have different applications for that. So, for example, they can be used as asphalt filler or a concrete filler, can be used in a cement. And it's not going to be toxic at the end of our process. So it's coming in, it's going out, the same intact. There is nothing in there. The chemicals being rinsed and being washed out of those materials as well. So there are different applications that we are working for to just even recycle that 99.9. There are some more R&D that we are doing with a couple of local universities in here in Vancouver as well to find a solution for something more meaningful and more, I would say, just making more money out of those 99% materials as well, because there are lots of ceramic-based materials in there that can be reused and recycled. But there are lots of applications that we are investigating. But right now, most of the materials are being used as a concrete fill, which is offset the carbon footprint in the concrete production, the cement production, and it doesn't have any cost for us to reuse them in concrete manufacturing.
Interesting.
The other question is about the scale.
Yeah.
And we started to just give you some scalability that we've done during the last 3 years of founding PH7. So I started PH7 in 2020. We got our state-of-the-art laboratory in 2021. We started all the R&D working with a couple of local universities here, and I started from a beaker. So it was a 400 milliliter beaker with 10 grams of sample, doing R&D with agitator, with different chemistry. And in 2022, we built our first prototype with about 50 kilo capacity of the raw materials, and it scaled it up to 100 kilo by early 2023. By end of 2023, we scaled it up to half a ton per day operation in a pilot operation. And now we are commissioning our 5,000 kilo per day operation in Vancouver. So the scale has been scaled up in the last 3 years from a beaker to a 5,000 kilo per day operation. And the goal is to build more of these 5,000 kilo per day operation around the world. So this is going to be our first plant that we call it demonstration plant. And commercial scale is going to be about 10,000 kilo per day capacity. And we will build 10,000 kilo per day capacity modular plants closer to the source of the materials. Doing so, and this is actually one of the main differentiative of our process compared to traditional processes that eliminate overseas shipments. And we localize the metal extraction. So instead of collecting everything, concentrating it and sending it to all overseas smelters in South Asia, in Europe, we just bring our process closer to the source and we extract the metals over there. So our target is to build more of these plants in North America, in Europe, in South Asia, in Middle East, South America, South Africa, Australia, and just expand our international presence over the course of the next 5 years.
If I could, Mohammed, I'd like to have a follow-up. Which this is coming up from the left field on you. Based on the scaling that you've done and the changes in the production day after day and how it's increased dramatically, can you relate the cost reductions to the scalability of every time you increase production, this cost becomes less and less to actually fulfill this activity? Is that
exactly? So that's the answer is yes. And how it happens, you decrease your overhead cost by increasing the capacity. So the chemical cost, the electrical cost is per kilo of the material. So it's not the direct cost is not changed, but indirect costs and overhead costs is changing dramatically and make this process more efficient, more economical. But the scale is very important for us. And that's why we ended up at about 10,000 kilo per day operation is our sweet spot, because we see that, okay, it's easy to process, it's easy to handle. We can scale it up easily to that stage while we minimize the cost, minimize the overhead and indirect.
Okay. Thank you. You answered out my other question. That 10,000 is the sweet spot. Is there any reason that you would even go higher or need to go higher in the future?
We will go higher in the future, absolutely. But right now, our focus is on the recycling industry. And recycling industry, we believe that 10,000 kilo for each region is a good number. So you get enough supply of 10,000 kilo. When we go to mining, that's completely different story. So it's going to be 10,000 tons per day.
Right.
So we actually bring our process, our technology to the mine. We start processing that, but it's going to be a huge scale because the scale of recycling and mining is completely different, completely just not even close to each other. And that's where we scale up our process significantly to meet the demand for mining operations. And I believe our smallest is going to be 10,000 tons per day operation for the mining. But in recycling, I believe that 10,000 kilo, just 10 tons per day is a really good number that builds regional recycling plants around the world.
And if I could, you're doing recycling. Is there a forecast of when you would go into the mining sector? Do you have an estimate of when you're thinking?
Yeah, so we are doing mining, prototyping and piloting this year.
Okay.
And we are working with different partners around the world, from North America to South America and Africa and even South Asia. The results are really promising. The mining is a little bit slower than recycling. So that's the main reason we started the recycling industry. It's easier that the barrier to entry is way lower in the recycling industry. So everyone is actually open to changes. It's easy to change the operation. It's easy to add an operation to existing operations. But in mining, it's not easy. So the permitting, for example, in North America is 10 to 15 years.
Right.
And when they get the permit, they don't want to change anything. They already making money. It's really hard to change. So I understand the challenges in the mining. And that's why it takes more time for us to get to the mining industrial scale. However, we came up with some kind of interesting business model that we believe it's attractive for mining industry. And that is focusing on their waste run. So we don't want to change any flow sheet that they already have. We don't want to change any operation existing as of today. We don't even want to touch. The offer to the mining industry is to the mines and we start processing the waste run. The waste rock that is already mined, that is already on the ground, but it's really low grade. It's not economical to running it through the existing process. It's lower than cutoff grade. So what we offer, we go to the mine and we start building the operation, the metals from their waste rock. while minimizing the changes in the mining and the mine site and increasing their revenue and increasing their metal production. So I believe that's a win-win situation, but still permitting needs to have some permitting in place. We need to back it up with lots of data from our prototype and pilot operation that we are operating in Metro Vancouver. My goal is next year, but hopefully maybe in 2 years we get to my commercial mining operation.
I mean, it's interesting, and I've got a question that you've partially answered, because I think you've talked about where sort of 3, 4, 5 years takes you. But what if we take throw a bit further into the future? What is the future of metal extractions and refining in a sustainable way?
So I'm meeting with a lot of refiners, mineral processors, mining industry, and I believe that the amazing thing that I love about all of this is everyone is on the same page. Everyone is actually wants to play their role. They want to have this vital role to get to our 2030 goals and 2050 goals. So by 2030, all of these refiners that I'm talking to them, they have a goal that we want to have 50%, at least 50% of materials coming from recycling, play our role into the circular economy. We want to offset our carbon footprint and GHG emission by 50%, at least by 2030. And by 2050, we want to do 100% recycling materials. If it's mining, 100% sustainable mining, and bring down our carbon emission by 0. So that's the goal that I see everyone is actually setting up. And new technologies such as PH7, other competitors that we have in markets that I appreciate every single of them, would be super helpful to get there. So it's not that only PH7 can play a role to get to our goals. It's just we need a lot of companies like PH7 to get there. We need lots of AI. We need lots of automation. We need a lot of changes that needs to happen with a fast pace to help the mining industry, mineral processing industry, and recycling industry to get to our 2050 net zero goals. So what I see personally in the future of mining and mineral extraction is we will see a lot of automation playing a lot of important role. We will see AI, and we will see new extraction technologies such as PH7 being implemented around the world to make mining and mineral extraction and metal extraction more sustainable. We will see wastewater processing is getting more efficient. We will see water consumption is coming down because of the new technologies. We will see ore sorting. We will see more efficient grinding processes. We will see a lot of more efficient processes down the road. And the startup ecosystem focusing on mining and mineral extraction is getting amazing results, promising results that can help mining industry. And the good thing, mining is getting open to testing these new technologies. And I believe the awareness is there, and hopefully we can see the change.
Thank you.
Thanks, Mohammad, for a great episode. What is the biggest takeaway for our listeners?
I believe the thing that we need to consider is that mining and mineral and metals are part of our day-to-day life. It's inevitable to just get away from mining. It's impossible. We need mining, we need metals, we need metal extraction in day-to-day life that we have in our laptops, phones, communication, all of that. We are using these metals that being mined. However, we need to do it sustainable. We have to increase recycling. We have to get to the circular economy as much as possible. We need to do this sustainable mining, and we need to be really mindful about resources that we have. We have limited resources on the earth. The grades of the metals that we are extracting is going lower and lower and lower and lower. And that's why it's getting more important to do recycling, to take recycling seriously and to get to the 100% circular economy down the road while doing more thrifting, which means that changing from high portion of metal in our product to way lower portion of the metals, considering that as an R&D moving forward, increase the recycling and do sustainable mining. The awareness is there. I talk to lots of stakeholders in mining industry, in metal extraction and recycling. Everyone wants to do their role. And companies like PH7 with a vision that we want to bring sustainability in mining and metal extraction would be vital and critical for our goals to achieve our net zero by 2050.
Thanks, Mohammad. Dave, what's your biggest takeaway?
I think the idea of recycling these precious metals, which It's my understanding that these precious metals are the kind of contentious issues, meaning certain countries have it and certain countries don't. And the fact that we can recycle it, I think it adds some security or allows a little, maybe this is too far, world beat, but some type of organization where it allows people to start extracting and using it that don't have it in their countries. So one, that I thought, wow, this is actually really not only for sustainable reasons, which is what we're all about and what we're all thinking about, but this will be really helpful as the world, and we will need more and more precious minerals going forward. So I think we get the best job in the world because we get to speak to people like Mohammad that think of this idea and be able to start it and then make it happen. And I say this frequently to a lot of our guests, Mohammad, I'm really looking forward to watch how your company grows, because I think you've got something that's pretty significant, and we need more of it in the world. So I found it really interesting and exciting to see as we go forward.
Thanks, Dave. John, what's your biggest takeaway?
Okay, Dave's taken part of my takeaway. So now I think what my takeaway is often when we've had these podcasts, we've been talking about things that, shall we say, are incremental change. And we tend to forget, or we think, oh yes, that's it. But we've got to have step change at times. And it requires a degree of boldness, courage and vision to make a step change. And I don't know, but I guess for PH7 successes, there's probably quite a few people who've tried to do something and haven't succeeded. But if it wasn't for people who tried, we wouldn't get the step changes.
Agreed. Thanks so much, Dave, John, and Mohammad, for a great episode. Have a great week.
Thanks, everyone.
Thank you. It's been really good.
That's all for today's episode of the 360 on Energy and Carbon podcast. Thanks for listening. Make sure to check us out on our website at 360energy.net and follow us on LinkedIn at 360energy Inc. Tune in to our podcast on Apple Music, Spotify, Anchor, or other listening platforms by searching the 360 on Energy and Carbon. You can watch the video recording and subscribe on YouTube at 360 Energy Inc. Email us your feedback at podcast@360energy.net or comment on our LinkedIn posts. See you next week.